So, let us illustrate this example for the sum, which is a local sum. So, A and B are two arrays, and we will compute local sums for some threads and then do the total. So, this is a code. So, I did it for bigger data set. Okay, I mean n is 10 power 8, typically that is what we want to do. So, we in fact we need the numbers for 10 power 8. No, sorry, 10 power 4. This is a 2D array, so 10 power 4. So, 2D arrays. So, I create these two arrays. We do not need the C. This is not required. I was doing it. So, there are 4 threads. Sum is initial sum. Well, I initialize sum to be 0, and I create a variable thread lock. So, these are all part of main program. These are run with process P0, master process. Then I define a function. This is a function, it is not part of the main program. Well, basically threads will run them. Next slide we will see the main program continuing. By the way, the Python function can be inside anywhere you can create. A C guy will not like that, but in Python you can put the function anywhere. So, we define this called global. So, sum is global, that when inside this function you should know that there are some global variables which is going to be accessed by the P0. So, block size is n integer division by max threads, start index and end index. By the way, in my last program, last class, I had made an error. There was a -1 was put in there, which is wrong. Okay. So, I corrected in the Colab, but your PPT has this -1, which you should remove. I had put I star thread number star block size, thread number, well, process number +1 block size -1. So, the -1 should not be there. Why? Because this in a range, the last index is last number -1. That was a mistake I had made. So, anyway, so local sum is just sum. This you have seen it many times. It is a 2D array, but I am dividing the data. So, please keep in mind, I am dividing the data along the rows. So, division is along the row. So, you can see that division is along the row. So, local sum is printed by each thread, and then I want to manipulate this global variable sum. So, thread log dot acquire, sum is increment or sum is updated with the local sum and then release. Okay. So, this is a function, and I need to now ask all the threads to execute this function. So, this is main program. Well, so these are also part of the main program, but okay, I say, well, this is in the initialization part. Okay. Now, this here main is knows those numbers n, a, b, c, so all that, but now we have main program. Main is like a function, but it is a main program. So, I get the time, thread is empty array, then I go for all the threads, I in range max threads. So, T is creation of threads. It is supposed to work on function array mult, argument is I, which is the thread index, append start. Okay. So, this all the 4 threads will be started one after the other, fine, and then I join them once. So, basically you have to put this function, otherwise your code will not run. So, once you are done, please join, that is what is being told here, and I print the sum. So, therefore, time difference is printed here, and this is to execute the main function. Without this, you can put in a terminal and execute the name of the file, but if you do this, then it will run on its own. So, it will basically start this main. Is that clear?
So, can you say again that main part?
Yeah. So, if I have only till here, okay, then how do I execute this main? Okay. So, this syntax I have kind of forgotten. If name equal to main, then main. So, this will start executing this. So, how do I run this? As Python name of the file, right. So, once I write this, it will execute start with this execution of main. If I do not have it, then typically the program start from the top and goes in a sequence. So, I need to say you need to run this main.